used in OSCEs. Suppose that we have the same checklist, but now we ask not for a borderline pass or fail, but we ask an overall rating in terms of clear fail, borderline, clear pass, outstanding performance. So there's more variation in the scale, particularly at the top end. Usually there will be a lot more students who score on the top end of the scale than on the bottom end of the scale. And using that information to set the passing score makes the resulting passing score more reliable. Let's see what we do. We use the checklist score and the overall rating as a scatter plot. We scatter the individual points in the plot. Subsequently, we calculate a regression function through it, and then we take the borderline point on this regression function to predict this checklist score, and that's our passing score. This method is much more reliable than the contrasting groups method and is applied a lot within OSCEs. It is cheap because the examiners are there. We can use their judgment easily because they see and observe the performance of the test takers while they're performing, so that's really easy. It is reliable because ultimately the passing score is based on a judgment across all the stations, across all students, and that's a very huge sample, which will lead to a very reliable outcome, and studies have shown that this outcome is indeed reliable, reproducible, meaning that suppose we had a different set of judges with a different set of stations with a different set of checklists, we would have come to the same sort of outcome in terms of passing score. It is credible because it's based on expert judgment who look at the performance in direct observation. The disadvantage is that the passing score is not known in advance. I've discussed two branches of methods. One is the absolute methods and the use of panels of judges to judge items. They have been used a lot with written testing, although there are possibilities to apply them, for example, in OSCE-based testing. Similarly, the borderline or the contrasting groups methods may be used in written tests, but they are also applied a lot in OSCE type of testing. The essence of the procedures may be applied to any kind of assessment method. They are not limited to a certain method. Right. We move on. In addition to the judgment of individuals, relative standard setting methods use the performance of groups as a reference group. And we already discussed the Vleuten method using the mean and 2 times the standard error of measurement as parameters to estimate the cutoff score. In the Vleuten method, there's always a fixed set of students or test takers failing the test. With a normal score distribution, the approximate failure rate will be around 15 to 17%. This percentage fails the test regardless of the competence of the group, regardless of the ability of the group. Therefore, Cohen proposed a different method. She also took the total test score distribution as a starting point, but instead of taking the average performance of the average test taker, she decided to use the best students, for example by picking out the P95 score. So the 95%, the percentile of the 95% is taken as a reference point And then again, this is set at 100%, and then again a rather arbitrary fixed cutoff score is taken from that, and that has been set at 60%, and below that point you fail the test. It is again a similar relative standard setting method as the Vleuten method, however with the advantage that all people may pass depending on where the P95 and the 60% may lie. It is highly practical, easy to do, cheap, but it's a relative standard setting method. It uses the average performance of the group as a starting point. Okay, it is not criterion referenced. Then we have finally compromise standard setting methods, which make a compromise between absolute and relative standard setting methods. One is the Hofstee method, which I will come to in a minute, or other combinations. For example, suppose, which we are using or have used for a long time with our OSCEs, we use the Vleuten method applied to the total OSCE score. However, if the total OSCE score is above 70%, the student always passes. And conversely, if the total test score is below 50%, regardless of what the Vleuten method may tell, a student has always failed. So you set the initial passing score as the relative standard setting method, and then you apply upper and lower boundaries to it. The Hofstee method is a very eloquent variation to that. What is done is you set up a passing score above which one always passes, regardless of test difficulty. Above that score, that student will always pass. Similarly, there's a minimal score. Below that point, you always fail, regardless of the test difficulty. Similarly, we set the lowest acceptable failure rate, beyond which you don't wish to make any more compromises. And similarly, a maximum, your highest acceptable failure rate. More failures you do not wish to accept. This provides a window between which we accept a compromise. By drawing the diagonal between in this particular window, and by plotting the cumulative test score distribution, there is an intersection between the diagonal of the window and the cumulative score distribution, and this is my passing point. Suppose the tests were more easy, then the score distribution would move up, my passing score would move up. If the score distribution was more if the test was more difficult, the opposite direction of the passing score would be the case. This is a very neat method, which is a real nice compromise between absolute and relative standards. There's also, this is the graphical explanation to it. There's also a mathematical explanation to this procedure, which can be found in the literature. The disadvantage is it's not easily explained to people. Right.